In this video, we are going to go over some review problems of functions. So basically the concepts, the objectives that we are going to cover are first, how do you evaluate functions? So that is what this question is asking you. A function is given to you, and the question, the 6 parts are asking you to evaluate the function at different inputs. So let's look at the first one, f of 2. So here, all that you need to do is you are going to replace your x with 2 and make sure that you use parentheses when you substitute so you don't make an error, a simple arithmetic error, right? So 3 times 2 is 6, 2 squared is 4, 4 minus 1 is 3, 6 over 3 is 2. When you write the answer, make sure that you write f of 2 is equal to 2 and not f of x equal to 2, okay? So in the next one, we are going to replace x with -2. Again, use of parentheses is really important when you're substituting negative numbers. So you have -6 over -2 squared is still +4. 4 minus 1 is 3. Therefore, this becomes -2. All right. So in the next one, we are going to replace x with -x. So wherever you see x, you're going to replace it with -x. And this is what happens. And again, when you square a negative, it becomes positive. So the denominator is going to become x squared minus 1. However, the numerator, you're multiplying 3 with -x, that is -3x. Okay. In part D, you are evaluating negative of f of x, meaning the whole expression is getting negated. So when you negate a fraction, don't apply the negative sign to both the numerator and denominator. Choose which one you're going to do. So I'm going to apply it to the numerator. So I have -3x over x squared minus 1. So remember not to do it to both the numerator and denominator, because if you do that, you're not actually coming up with the opposite, because negative over a negative is still a positive. So you're not changing your original expression at all. So when you're negating the whole thing, you have to negate only the numerator or the denominator. So f of x minus 2, again, I'm going to replace x minus 2 for x. And then I can either simplify or leave it like that, depending upon how you're expected to leave your answer. But if I'm going to do this, I will expand the x minus 2 the whole squared. Remember, when you expand a binomial such as that, a minus b the whole squared, it becomes a squared minus 2 times a times b. My a is x, my b is 2. So 2 times x times 2 is 4x plus b squared. 2 squared is 4. And then there is also a -1. So if you simplify this further, you have 3x minus 6 over x squared minus 4x plus 3. And I suppose you can just leave it like that. Or you could factor and simplify, but I don't think you can factor and simplify, so I'm just going to leave it like that. So the last part was f of 2x. So I'm going to replace my x with 2x in this case. So I have 3 times 2x over 2x the whole squared minus 1. 3 times 2x is 6x. 2x the whole squared is 4x squared minus 1. So remember, the 2 has to be squared also. In this set of problems, you are going to find the domain of a given function. So again, to recap, what do you mean by domain? Domain is nothing but the set of the values of all the input that would result in a real output. So we are just going to find out all the allowable input so that the function output is a real number. Now, most often, your domain is all real numbers. Now, when do you have to pay attention to a domain restriction? So here we're going to focus on two cases where you have to pay attention to a domain restriction. One, you have a fraction. So whenever you have a fraction and the denominator has an expression with a variable, then you have to make sure that whatever the value that that variable takes does not make the denominator equal to zero. So for fractions, your concern is you're avoiding a division by zero. So how do I make sure what values of x are going to make my denominator 0? I have to calculate. So I am going to see what values of x will make my denominator 0. To do that, I set my denominator equal to 0 and solve. So here you can either use the square root method or the factoring method. I'm going to do factoring and I factor it like so. I have two factors. If I set the first factor equal to 0 and solve, I will get x equals 3. If I set this factor equal to 0 and solve, I will get x equals negative 3. So what this tells me is that in my domain, I have to restrict these two numbers, meaning x cannot equal 3 or negative 3, right? So if all other numbers are allowed except 3 and negative 3, you can write the domain in the interval notation like so. Negative infinity to negative 3, everything is allowed except negative 3 itself. Then everything between negative 3 and positive 3 is allowed, and then 3 to infinity is allowed. The only two numbers that were not are negative 3 and positive 3 themselves. In the second problem, you have a radical with an even index. So this is a square root. So the index is 2. So whenever you have an even radical such as this, you have to make sure that the radicand, that is the expression within the radical sign, is non-negative, meaning this any x value has to make sure that that value of the whole expression is non-negative, in other words, greater than or equal to 0. So solve for this, subtract 2 from both sides, you get this. And you have to now divide by negative 1 or multiply by negative 1. And remember, whenever you multiply or divide by a negative, the inequality will flip. So the sense of this inequality is now flipping so that instead of greater than or equal to, you end up with less than or equal to. So if you want to visualize this on a number line, what you're saying is that all of these values which are less than or equal to 2 are the only allowed values for x. So you can write that domain in an interval notation like so. Okay. Now, in this example, you have a fraction. And again, when you have a fraction, you have to make sure that the denominator is not equal to 0. In order to find out what values of x will make my denominator equal to 0, I set it equal to 0 and solve. So I factor this, I get two factors, and the solution for the two factors are these, which means I had to restrict both of them from my domain. So these two are not allowed, which means what is allowed? Everything else, right? So negative infinity to negative 3, negative 3 to 1, and 1 to infinity are allowed. So in this next problem, you have a fraction as well as a radical, and the radical happens to be in the numerator, right? So I take this radical. So the first thing that I do is I will see, because I have a radical in the numerator, I have to make sure that any x value that I input makes that expression non-negative. Solve x is greater than or equal to negative 1. I can put this on a number line so you can visually see it. So this one, -1 is somewhere here, let's say, right? So I'm saying that all of these values are permissible from my first possible restriction. Now, let me go and look at the second one because I also have one more thing that I have to be careful about, which is I cannot have any zero in the denominator. So I set it equal to 0 and solve. I get two numbers that are not allowed. Which are they? They are -2 and +2. Now, my combined final restriction should incorporate both of these. So I see where these are. Where is -2? -2 is here, right? It is less than -1. I don't have to worry about that. Now, +2 is here. So you want to find the interval that is an intersection of both of these uh, allowed domains, right? So in order to do that, what is it that I see? I see that my final domain, when it incorporates both, will be all values from -1 to 2 union 2 to infinity. So -2 we did not bother because it was already outside the interval that was allowed from the first restriction. So we didn't bother about it. And +2 happened to lie in that interval that was allowed from the first, but then I remove it because of the restriction from the denominator, and my final domain looks like this. In the next question, we are going to find the difference quotient of the given function. Difference quotient is given by this formula. So I'm going to do it all in one step. So f of x plus h is nothing but I replace the x in the original function with x plus h. So I will just set it up like so. Wherever I see x, I'm replacing it with x plus h. So this is So all of these is my f of x plus h. Okay. Now I'm going to subtract f of x. So whenever I subtract something and there is an expression that follows, please make sure that you put the whole thing within parentheses so that you remember to apply the negative sign to each term. So then I'm going to expand my first, this binomial here. So I have x squared plus 8 squared plus 2xh plus x plus h plus 1. Then I take out everything from this parentheses. I distribute the negative sign, and this is what I have. Now in the next step, I'm going to distribute the -2 here. Then I'm going to see what are all the common terms or like terms that can get cancelled. So let's see that. So positive 2x squared, negative 2x squared goes away. Negative x, positive x goes away. -1, +1 goes away. Now what am I left with? I'm left with -2h squared minus 4xh plus h all over h. And as you can see, h is a common factor of the numerator. Factor it out. Then you have -2h minus 4x plus 1 all over h. Now at this point, I can cancel this and this. So it's 1 over 1, right? And so what I'm left with is this. And that is my answer. Okay. So in this problem, a graph of a function is given to us, and we are asked to find some information from the graph. The first is what is domain and range. So domain is the set of all the input, right? So if you look at this graph here, it looks like all the x values, let's assume that this is x and this is f of x, all the x values are between -4 to +3. Now, where do they come from? So the -4 comes from here, the +3 comes from here. Then what is the range? The range is all the y values which are from -3 to +3. Again, where do they come from? Comes from here to here. Okay. So the next question is, what are the intercepts? The intercepts, what are the x-intercept and y-intercept? It looks like there is only 0, 0. That is the only place where the graph meets either the x or the y-axis. What is f of -2? So you're trying to find the y value that corresponds to an x value of -2. Now, where is that? This is the value that you're interested in, right? So the answer is going to be -1. So f of -2 is -1. The next question asks you, for which values of x does f of x equal -3? Now here you're interested in the x value now, where the function value is -3. So now you're looking at -4. Because when x is -4, y is -3. The next question is asking you to solve for f of x greater than 0, meaning for what values of x are the y values more than 0. So I'm just going to visually just show this to you this way. So basically what it is saying is all the points here, this portion of the graph, have y value greater than 0. Now, what are you expected to find? You're expected to find the corresponding x values. That's what you're expected to find, right? So the answer to that question would be 0 to 3. 3 is included because at 0 itself, it's not greater than 0, it is equal to 0. Whereas when x is equal to 3, the y value 3 is definitely greater than 0, right? So I would say 0 to 3. Graph f of x minus 3. So x minus 3 takes my function or my graph to the right by 3 units. So every point moves 3 units to the right. So 0, 0 goes and becomes 3, 0. 3, 3 becomes 6, 3. -2, -1 becomes 1, -1. -4, -3 becomes -1, -3. So the whole graph just moves to the right by 3 units. So I connect them the way that this was connected here. My points look super off. It's okay. It's like this, right? So the whole thing is moved 3 units to the right. So this blue graph now is f of x minus 3. So the next one is f of 1/2 of x. So here, this is a horizontal stretch. So how do you do that? So in order to complete this, what you would do is, so in a vertical, so for example, if you had 2 times f of x, all the x values will remain the same and the y values are getting multiplied by 2. Now here what happens is your x values are getting divided by 1/2 and the y values remain the same. So let me just take the points and then write them out so that you can see it. So I have -4, negative. So these are the original points, right? You have -4, -3, -2, -1, 0, 0, and 3, 3. Now what I'm going to do is I'm going to take every, oh, I'm sorry, I wrote it here. So I'm going to take every x value and I'm going to divide that by 1/2. Okay. And then nothing is going to happen to the y values. So dividing by half is the same as multiplying by 2. So this becomes -8, -3, -4, -1, 0, 0, and 6, 3. So I'm going to plot them. -8, -3. I don't know whether I have room for it, but I'll try. -8, -3 is somewhere here. Okay. Then I have -4, -1. Then I have 0, 0. Then I have 6, 3. Connect them. And that is the graph of f of 1/2 x. Okay. Next one, graph negative f of x. So negative f of x is nothing but a reflection over the x-axis, meaning the x value remains the same, the y value becomes opposite. So this point, -4, -3, now becomes -4, +3. 0, 0 remains the same. -2, -1 becomes -2, +1. 3, 3 becomes 3, -3. So my graph becomes like this. It just flips upside down. And that is the graph of negative f of x. All right. Sorry about all the colors. In this question, a graph is given to us and we are asked a bunch of questions. The first is domain and range. So now we know how to write domain and range. So to write the domain, look at all the x values. Now look at how this graph is starting all the way from the left, right? You see the arrow. So that means the domain, the leftmost will be -infinity and the rightmost value is +4 for the domain. The range again all the way from the bottom, -infinity, and stops at +3 on the top. The question is asking you for what values of x is the function increasing, decreasing, and constant. So increasing, you're following the graph and you're seeing for what values of x is the y value increasing. So if you see the first portion of the graph, your values, all the y values are going up, 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 up. So that means in the interval -infinity to -2. So you're looking at the x values, but we are following the growth of the y values. Okay. So in that interval of -infinity to -2 of the x, the y value is increasing. Where else is it increasing? It is also increasing in this interval, correct? So the next interval that it is increasing is 2 to 4. Okay. So then where is your graph decreasing? Your graph is decreasing in this interval, right? So it is decreasing in the interval -2 to +2. So it's not constant anywhere. Okay. Next question is asking you what are the local maximum and minimum values? So you see how this graph turns here at this point and it turns at this point. So this -2 comma 1 is a turning point and that y value is a local maximum because in the interval surrounding that point you see that that is the highest y value. So I would say local max is 1, which is the y value, at the x value of -2. Local min is -1 at an x value of positive 2. The next question is, does this graph have any absolute maximum or minimum? It has an absolute maximum, right? Because this number, the number negative, this value of 3 is the highest value that any y value has in this graph. So it has an absolute maximum, which is 3, and that happens at x equals 4. And there is no absolute minimum because your graph goes to negative infinity down. Does this graph have any symmetry? Well, if this graph had ended at, the leftmost point was -4, -3, then yes, it would have had a symmetry. However, you see that the graph is going all the way down on the left, whereas on the right, it stops at 4, 3. Therefore, I would say that it does not have any symmetry. Is it even, odd, or neither? Again, if it had not, um, stopped, if it had not continued on the left, then yes, it would have been an odd function. Whereas now it did, therefore it does not have it doesn't have any symmetry, therefore it is neither even nor not odd. So in order for a function to be even, it has to have y-axis symmetry. In order for it to be odd, it has to have an origin symmetry. This function would have been declared odd and would have had origin symmetry had you not had this portion going down like that. Finally, what are the intercepts? So the intercepts are, it has 3 intercepts. It has -3, 0, 0, 0, and 2, -1. I'm sorry, what did I say? 0, 0, and 3, 0. I'm so sorry. So I said, for some reason, 2, -1. I don't know why I said that. Okay, so the 3 intercepts are -3, 0, 0, 0, and +3, 0. In this question, we are going to determine even or odd algebraically. So in order to do that, the first step is to evaluate f of -x. So you're going to replace every x with -x, and negative when raised to an odd power stays negative, and negative times a negative is positive. So now if you compare f of x and f of -x, you see that f of -x is exactly the opposite of f of x, meaning every term has changed sign. When that happens, you declare the function odd. So in the next problem again, I will replace the x with -x and see what happens. So when I do so, negative raised to an even power becomes positive. So then I see that I get back the original function. That means g of -x is the same as g of x. Therefore, this function is even. Next example, I do the -x again. So I replace every x with -x. Then I simplify. This is what I get. Now, what I observe is that g of x and g of -x are not the same, but neither are they opposite of one another. Because if it is opposite, every term will change sign. So my conclusion is this is neither even nor odd.